Dear viewers, welcome to the session on external interrupt and LED interface. Let us look on what is an interrupt. Or before that, whenever we write a program, there is always a call to a function. And when you call a particular function, the control is transferred to the specified location, executes a certain set of instructions and comes back to the main program. That's what is calling a function. And when you call a function, it's very well known to us that at what position or at what instruction or after what instruction the call to a function is done. But interrupt is totally different. Interrupts are the ones which are unpredictable. We do not know when there will be an interrupt or when there will be a requirement, when there will be an external signal that occurs which requires the functionality or that requires the service of the processor. And normally the interrupts are external. To give an example, let us assume that there is a furnace in any process industry, and then the furnace is expected to maintain a particular temperature between the range, say, of X and Y. And whenever there is a variation in the temperature, then it will send an interrupt to the controller. So what is expected if the input, rather if the temperature goes below X, maybe we need to increase the temperature, and when the furnace temperature goes beyond Y, then we have to cool it down. So what is the job of the controller over here? The controller will respond to that interrupt, and based on the input, whether it is less than X or greater than Y, provides the service. Now, don't you think this is really advantageous? On the contrary, if at all the processor has to keep on monitoring what is the temperature of the furnace, there the processor time is unnecessary wasted. But with interrupt, you have the advantage of saving the processor time, and the service would be provided only when the external, or it could be your on-chip peripherals, require the service of the processor. Fine. So in this session, we will be discussing on the interrupts associated with the LPC1768. And then we will write a program for a switch which will act as an interrupt, right, as an external interrupt. Based on the position of the switch, the LED would be on or the LED would be off. So before going to understanding of the program, let us quickly understand the theory behind the interrupt. What are the different resistors that are associated? Once we understand the fundamental of the interrupts and the resistors that are associated with it, then programming becomes a simple job altogether. So the external interrupts of LPC1768, to understand that, let us understand the concept of an interrupt. As I said, interrupts are the ones which occur without any notification. They can occur at any position, at any time, or during any instruction being executed. They are unpredictable. But nevertheless, whenever there is an interrupt to a main program or the normal flow of the program, the controller will always complete its current execution and then looks into what is the interrupt, from where the interrupt is come, and what should be done on the occurrence of that particular interrupt. Now we have with the association with the LPC1768 EINTX pins. That means there is external interrupt pin 0, 1, 2 and 3. So if you recollect the pin configuration of LPC1768, we have the EINTX, that is 0, 1, 2 are the external interrupt pins. So as I gave an example of a furnace, which has to the output of the furnace has to be connected to, say, for LPC1768, then that can be connected to either of these pins of EINT X. The LPC form in 1768, as said, has four external interrupts, and they have been named as EINT0, EINT1, EINT2, and EINT3. With respect to the LPC1768, again, the pins, they are multifunctional, and hence these four interrupts are available on these multiple pins, right? They are not to one, but you can see along with the different pin configurations, you would observe one of the functionality to be either EINT0, 1, 2, or 3. Like any other peripheral is multiplexed with a particular pin, so is the external interrupt. Here is the representation of how actually an external interrupt occurs and what happens whenever an interrupt occurs. So as said, there are four external interrupts which are being connected to LPC1768. So we have the normal application which runs, and assume somewhere in between here, right, there is occurrence of an interrupt. That interrupt could be either from EINT0 or it could be from EINT1, 2, or 3. Then what happens? The controller will complete its instruction if at all the interrupt occurs somewhere in between the execution of an instruction. It completes, then the control is transferred to the ISR. What is ISR? Interrupt service routine. What does this routine basically consist of? It consists of a set of instructions to be executed whenever an interrupt occurs. I get back to you the example that I took in the beginning to say that a furnace has to maintain the temperature. So if at all the temperature goes below X, there would be an interrupt. And let us assume it is with EINT0. Now, what are we supposed to write in the interrupt service routine? We are supposed to write that increase the temperature of X by a factor of some value A. On the other hand, if the temperature has already been beyond Y, then you need to write saying that you reduce the temperature by a percentage or by 10% or by a factor of B. So that goes into the ISR, wherein this ISR will be executed only specifically for the occurrence of an interrupt. So once we finish the execution of the ISR, then the controller would be again transferred back to the normal program or the normal application from where it had really stopped. It may look pretty simple enough, but nevertheless, there are lot many internal operations that happen. The processor registers which are being used in the normal application have to be put onto the stack. The context has to be saved, and then a new context of the ISR has to be taken by the ARM controller. So in the new context, it's basically the execution of the interrupt service routine that takes place. Once it finishes the execution, then it has to extract back all the registers, or rather we call in general the context of the main program into the current execution and start off executing from where it had stopped. So, you could find there is some amount of similarity between call to a function and the interrupt. But the major difference, what I said was, if it is a function, you're sure that after 5 instructions, I have a call to a function, or after 10 instructions, I have a call to a function, and the control is transferred, executed, and comes back. But with the interrupt, you really do not know when will the interrupt occur. Fine. So it is unpredictable. It can occur in any at any point of time during execution of X instructions, or it could be Y instructions. It could also be in between a particular instruction also. All right. So having understood, let's go ahead with the port pins that are being configured for the external interrupts. So the external interrupts, right, are being configured with P2.10, then P2.11, 12 and 13, wherein the first or the default functionality is a GPIO, and the first alternative function for P2.10 is the external interrupt 0, P2.11 is external interrupt 1, P2.12 is external interrupt 2, and P2.13 is the external interrupt 3. Well, you have other functions which is not in the scope of this particular session. Our concern is with respect to the external interrupts. So we understand that P2.10, 11, 12 and 13, their first alternative function would be the external interrupt 0, 1, 2 and 3. Please remember this. This is what we are going to use, right, into our programming. Fine. Don't forget. Remember that it is a first alternative function for the respective port pins. Now let us discuss about the resistors that are associated with. So as usual, we need to write the pin select resistor. So the pin select resistor, now we are going to write for what? It's going to be written for the first alternative function. Till now, all my sessions that you have seen, they are the normal GPIO, wherein we have seen that pin select is always equal to 0. But this is a new value that we are writing onto the pin select in association with the external interrupt. Now, other than that, we need to program three important resistors for the external interrupt. They are the external interrupt initialization flag, or it is external interrupt in general. So this is an interrupt flag resistor which contains the bits corresponding to the external interrupt 0, external interrupt 1, 2 and 3. So when you write a value of 1 into the respective bits of the EXTIN, that particular interrupt would be enabled. Okay, right. The next one we have is the external interrupt mode and polar. Now, whenever there is an occurrence of an interrupt, you have got different mode. That means whether the interrupt that occurs is the level or it is the edge. Okay, like for example, if I take and switch, obviously it is a level. But if you take some transition, a monostable output or something, there is a transition that's happening, fine, then it will be an edge. And when it is level, you also need to look into whether it is active high or active low. So the extern mode and extern polar are interrelated, which means that if at all you say that the external interrupt has the mode of level, which means that the polar, the external polarity would either be active high or active low. On the other hand, if you say that the external mode, interrupt mode, right, is an edge triggered, then what is the corresponding polarity? It can either be a rising edge or it can be a falling edge. Right? So these two resistors go hand in hand. Here is what is the description that we have given for all these three resistors. So external interrupt, the lower 4 bits will tell us which is that particular interrupt, external interrupt, whether it is 0, 1, 2 or 3. While for all these three resistors, the bits from 4 to 31 are reserved. We are not using them. And the next one, when we talk about the external mode 2, 3 or 1, what are we going to write in this value? We are going to write either a value of 0 or a value of 1 in the mode resistor. Now, if you write a value of 0, what does it imply? It implies that the external interrupt is level triggered. If you write a value of 1 in the mode, it means that the external interrupt is edge triggered. Similarly, by writing a value of 1 into the polar, that is polarity resistor, will indicate that the external interrupt is active low or the falling edge, which depends upon what is the value returned into the external mode 0. Similarly, when you write a value of 1, it implies that the external interrupt is active high or it's a rising edge. Again, I take a small example over here. I said if you write, let us take an example of external interrupt 0. It's being used. So what we'll write here? We'll write a value of 1 in the 0th bit. Now, if I write that the external interrupt mode is 1, what does that mean? It is a edge triggered. Next, in the polar, I can either write a value of 1 or a value of 0. Now, if I write a value of 0, it means it is on the falling edge. And if you write a value of 1, it means it is on the rising edge. Now, if the external mode, right, is with a value of 0, it means it is a level triggered. So with the level trigger, what are the possibilities? Either it can be active high or it can be active low. Then what I need to write in the external polarity is either a value of 0, which means that the external interrupt occurs whenever there is an active high. If you write a value of 1, it becomes the active low. Fine. So this is how we are going to program the bits into these resistors. So all these 4 resistors are very important for us to program the LPC1768 for any external interrupt based programming. So having understood with this, let us go with the programming steps. That the programming steps that I'm going to discuss over here is going to be general, and then we will take up with a specific one to the lab discussion that we are going to do. Right. So the programming steps would mainly require what is the interfacing diagram that we go in for. Fine. So for LPC1768, what is it? It is the external interrupt INT3 that's being used. Again, I said it's a board specific, where we have the jumper being connected as the JP6 and there is a switch. So the moment you press the switch, there is a path that is being set across. Fine. So when the external interrupt through this particular switch or external interrupt is being provided to the input, switch being pressed and there is a path that goes. So this is how is the connection diagram of the external interrupt onto the ALS board of LPC1768. Now coming to the the program that we go, it is P2.13 is the external interrupt 3. Hope you have recollected. I did mention, right, that you need to remember these pins. Okay, the table that I had shown, P2.10, 11, 12 and 13, wherein the first functionality is GPIO and the second functionality is the external interrupt 0, 1, 2 and 3. And then there is an LED which is connected to P2.12. Please remember, P2.12, you have the LED being connected, and P2.13, we are going to program it as an external interrupt 3. What are the steps? Configure the pins as an external interrupt for the pin select X resistor. So in correspondence to P2.13 and 12, obviously it would be the pin select 4 that we'll be using in our program. Next, clear any pending interrupts in the external interrupt. So before there is an execution of any interrupt, or when the controller enters into the interrupt service routine, it sees that the pending interrupts are being cleared, so that during the execution of the current ISR, it stops from the other interrupts entering or interrupting the current execution of the ISR. So that's the second step that goes. Next, we need to configure the external interrupt X, that is 0, 1, 2 or 3, either as edge or a level trigger into the resistor of external mode resistor. And then we need to select the polarity, whether it is the falling edge or the rising edge, if it is an edge trigger, or it is active high or active low if it is a level triggered. So these are the three resistors that have to be written across. And then finally, we need to enable the interrupt by calling this function. So this is an inbuilt function that we have, that is NVIC. NVIC in the sense nested vector interrupt controller underscore enable IRQ, and what we are passing over here is nothing but the IRQ number. If you are using first, you specify IRQ as 1. If it is a 0, IRQ as 0, or IRQ as 1, 2 and 3. Now we will look into the program. The void EINT3 underscore handler, since we are using or we are calling a function NVIC enable IRQ, you need to give the prototype here, define the function which will consist of the interrupt subroutine that's written. I'll come back to this in a couple of minutes once we go through the main program. Let us keep it on hold as to what is this void. It's very similar to the function prototyping that you do, but it's a bit different over here. And then we have used a Boolean flag which is set with a value of 0. These are the initializations that need to be done, and let us understand these a bit detail. The first statement written here is pin select 4 ORed with 0x4 remaining all zeros. As I said, the problem here is what? We are going to use the external interrupt 3 which is connected to the switch. So once you press the switch, an interrupt occurs to the main program, and what we are writing in the ISR is the glowing of the LED. Second time you press the switch, it puts the LED off. Okay, that is what is expected from this particular program. Fine. So what is written into the pin select 4? What is this value corresponding to? 0, 1, 0, 0. The pin select 4 resistor is a 32-bit resistor which has got 2 bits associated with P 2.0 to 2.15. Okay, so when we write this 4, what does that imply is, it implies bit 26 and 27 are associated with P2.13. And we know that P2.13, you have the external interrupt 3 being connected. And this external interrupt 3 is the first alternate function. And hence, those bits, that is 26 and 27, should be written with a value of 0, 1. And remaining all values are 0. So if you get the nibble equivalent, it will be equal to this value of 4. What is it? It's basically 27, 26 with a value of 0, 1, and 24 and 25 are with a value of 0, 0. Now coming to the next initialization statement, we have used an ampersand over here. Here OR indicates we are not altering any of the other pins. They may be used for some other function, but we are not altering. We are just making bit 27 and 26 with a value of 0, 1 corresponding to an external interrupt 3, which is the first alternative function on P2.13. Hope it's being clear to you. The next statement is pin select 4 ANDed with the previous value but the value what we have given here is FCFF. So any value ANDed with F will retain the same value. Fine. So these bits, that is 000, whatever we have, again we are not altering any of the bits. Our main concern is only with the bits 24, 25, 26 and 27 of pin select 4 resistor. And 24 and 25 is associated with P2.12, and there we have the LED being connected. When you have the LED being connected, it means that it is a normal GPIO function, and hence the bit 25 and 24 will be 00. I'm explaining you how is the value C. Right? C corresponds to 1100. In the previous statement, this 11, I mean already for 26 and 27, we have written it with 01. I don't want to alter it at all. That's why we are ANDing it with a value of 11. So when you AND it with a value of 11, in the bit position 26 and 27, we still get a value of 01. With the same, we also want to make P2.12 as a GPIO. That is bit number 25 and 24, and hence we have written with a value of 00. So the value C, which is written on to the bits 24, 25, 26 and 27, will make P2.12 as a GPIO and 2.13 for the external interrupt. Very, very important to be understood. Fine. The next is normal, what we have already discussed. The DIR resistor, fine, should be made 1 for the corresponding P2.12 because it's a LED and output. So to make any bit of the DIR, I mean any bit as output, it should be written with the value of 1. And then we have kept the LED being on initially, we set. Next, these three instructions, right, initializations rather, are associated with the external interrupt. And you know, it's only with the lower 4 bits or the lower nibble. The value 8 is 100, which means the third bit is being made as 1, implies that it's being cleared off, the interrupts are cleared, and moreover it is the external interrupt 3 which is being used. And in the external mode we have written a value of 1. What does that mean? When you write a value of 1, it is the edge triggered, right? It is the edge trigger that goes. And then we have written it to be as 00, which means it is corresponding to the falling edge. Okay, so these are the initializations that are being done. And then we call the interrupt function. Now what happens here is the controller is executing all these, and you have enabled rather the external interrupt 3. Somewhere after enabling, the controller is doing some job, and then there is a switch that is being pressed. What happens? The control would be transferred to this NVI, that is, it is the ISR, and we know that every interrupt is associated with a particular address. They all are vectored interrupts. So the control would be transferred, the program counter would be automatically loaded with the address of the external interrupt 3, and then we have the function written for the ISR. So as you saw in the main program, we have called this function, and this is the function for the interrupt service routine. What are we doing in this interrupt service routine? The problem statement says that the switch is pressed, LED is on, switch is released, the LED is off. So you're clearing off all the interrupts so that there is no another interrupt within this ISR. And we'll check the status of the flag. Now in the beginning, we have already done the flag equal to 0. So the condition becomes true here. It enters and then we are clearing off the LED. And when we clear the LED, we are setting that boolean flag, the flag with 0xFF, and then you exit. When you exit, where will the control, where will the control come? The control would come back to your main program, waiting for the switch. Now you press the switch again. What happens again? It goes to the ISR, right? And what is written in the ISR now here? Again it comes here, it checks for the flag. Now for the second time, the flag value is now FF. So will it execute this part of the code? No, it comes to the else part. So what are we doing in the else part? We are putting the LED off again. Fine. So in this way, you keep on pressing the switch once the LED glows. Next time you press the switch, the LED is being put off. Hope you have understood this program, and then let us see how it's being downloaded on the hardware, that is LPC1768, and we will observe the output. Browse the external interrupt. The X file is created. So where is the external interrupt that we are talking about is this one. This is the external switch. As you can see, external interrupt. So we have the switch as well as the LED corresponding to the external interrupt EINT3. So you see the LED is off, that means the flag state is off. So when I press, the LED is on. When we release, it's still on. Again I press, it goes off. Right, so it is program is you press once, you make the LED on, you press another time, the LED is put off. Okay, so this program basically makes us understand the usage of an interrupt based programming by putting the LED on and off. Thank you. Right. So we saw here in the program, as said, you press the switch, right? Once you press the switch, then it comes to the state where the LED would be put on. The LED remains on. Only when you press second time, it is off. Why? Because we have used this flag. Flag is holding the status of that particular switch, which makes it put either into the on state or the off state, or the LED being put on or the LED being put off. Hope this concept of interrupt programming and how do you interface an external interrupt to LPC1768, right, to put the LED or to glow the LED on and off is clear. For any queries, please put it in the review comments, or you can very well mail to me at rupakulkarni-ece@dsatm.edu.in. It would be my pleasure to get your queries clarified. Thank you. So in the next session, we have the interfacing of keypad and LCD to LPC1768. See you all in the next session.